Ladder logic is the most used industrial programming language on Earth. It runs the elevator in your building, the conveyor at the airport, the bottling line at every brewery, the traffic light at every intersection. And once you understand 5 shapes, you can read all of it. This video covers the whole language in one sitting. No hardware, no vendor software, no prior experience, just a browser and 6 minutes. Ladder logic was invented in the late 1960s. Before it, every factory machine was controlled by a wall of physical relays, timers, and counters wired together by hand. Changing what the machine did meant rewiring the wall. When programmable controllers arrived to replace those walls, the people maintaining the machines were electricians, not software developers. So the new digital language was deliberately drawn to look like the relay schematics those electricians already read every day. The 2 vertical lines on either side of the rung are power rails, like the 2 sides of a wall outlet. Each horizontal rung is one rule. The left side decides whether power flows. The right side decides what happens when it does. That is the whole conceptual model. 60 years later, it is still the dominant industrial language because that design choice still works. The first primitive is the contact. A contact is a switch on the rung that reads an input. A normally open contact is drawn as 2 short vertical lines with a gap in the middle. When the input it reads is off, the contact is open and power does not flow. When the input is on, the contact closes and power flows past it. A normally closed contact is drawn the same way, but with a diagonal line across the gap. It behaves the opposite. When its input is off, it is closed and power flows. When its input is on, it opens and power stops. That is the entire contact family. 2 shapes. Read an input. Pass or block power. Every industrial rung is built from these 2 pieces. The second primitive is the coil. A coil is drawn as a circle, sometimes with parentheses, sitting on the far right of the rung. The coil is the output. It represents the real device the program is controlling: a motor, a valve, a light, a solenoid. When power reaches the coil is energized and the device turns on. When power does not reach it, the coil drops and the device turns off. A simple rung is 1 contact in series with 1 coil. If the contact is closed, the coil energizes. If the contact opens, the coil drops. That is the doorbell pattern. Press the button, the bell rings. Release the button, the bell stops. Most industrial logic is more interesting than this, but it is all built on this one shape. The third primitive is the branch. A branch is 2 parallel paths on the same rung. Either path can carry power across. Each path can have its own contacts. If contact A is closed on the top path, power flows. If contact B is closed on the bottom path, power also flows. If both are open, power does not flow. This is, or logic, drawn visually. Branches are how every multi-button machine is wired. A motor that should start when either of 2 operator stations presses start is a single rung with 2 parallel contacts and 1 coil. Branches stack. A rung with 3 parallel paths is, or across 3 conditions. Branches can also nest inside larger branches when the machine has more rules. The fourth primitive, and the most important one, is the seal-in. The seal-in is how a real machine stays on after the operator lets go of the button. A bare contacting coil rung only runs while the button is held. That is no good for a conveyor or a motor. The seal-in pattern fixes it with a parallel branch and 1 extra contact. On the main path is the start contact in series with a stop contact, then the coil. In parallel with start is a second contact that reads the coil's own output. When the operator presses start, current flows through the main path, the coil energizes, and the device turns on. Now the coil's own contact in the parallel branch closes. Even when the operator releases start, the coil keeps itself energized through its own feedback contact. The device stays on. To turn it off, the operator presses stop, which is a normally closed contact. Stop opens, current stops, the coil drops, the feedback contact opens, and the rung resets. This is in literally every machine. Every conveyor belt, every motor starter, every pump, every cooling fan that has a start and stop button. Once you can see the seal-in, you can read every industrial ladder rung. With those 4 primitives in place, you can read a real industrial rung. A typical motor starter rung looks like this. On the far left, a normally open contact for the start push button. In series with it, a normally closed contact for the stop push button. In series with that, Another normally closed contact for the motor's overload relay, a safety device that opens when the motor draws too much current. In parallel with the start contact, a normally open contact reading the motor coil's own output. That is the seal-in. On the far right of the rung, the motor coil itself. 5 shapes. 1 rung. Every motor in every factory you have ever walked through. The first time you read it, it looks dense. After a few rungs, the shape jumps out, and you read it as fast as a written sentence. Open the simulator at plcsimulationsoftware.com and write a seal-in rung yourself. The latching and sealing-in lesson on the free tier walks the pattern step by step, with the rung running live in your browser. You can press start and stop and watch the coil hold itself on. Next video covers free paths to the Logix Pro alternative. What is real, what is sketchy, and the cheapest legitimate route to learning Allen Bradley. Subscribe. There is a new video every Tuesday. See you in the next one.